Okay, I just wanted to show the schematic I was using in the last video. So the battery, 1.2 volts, it's got some ferrite beads that it's going through. It's like a component ferrite, something like 29 ohms at so many megahertz. I've got a big 16 volt capacitor across that, which does filter quite a bit. And without that, the lights actually go dim, and the current goes up because of the AC going all over the place. So 1 ohm resistor here, that's the waveform that we get across that, and 22 microhenry choke, 1 mega ohm resistor. The primary is hooked up just as you see it. Top of the coil had to hook to the bottom because I think they have to be kind of out of phase or whatever. They're all wound the same direction, however. So the taps I can adjust on the primary. I can also adjust the capacitance up to 360 picos. It's not quite at the limit. When you tune it, you want to set that in the middle so that you're not maxed out and you have the ability to adjust. And this is the emitter base feedback I was talking about. So there's an LED with two 1N4148 diodes going to the base, and then also parallel to that I've got that 12 microhenry coil with the 400 picos in series, and that's also doing this. And I've got a program now that the same one that backup CPU is using, and it's a really great program. It's called Every Circuit, and I think it might be only available on the iPad, but anyway, it's a really good program. But the thing is, with this, it's absolutely critical, and it was, through tuning this, you could get some action going here. But in the simulation, these have actually no effect, no matter what parameters I set. So there's something about this that the simulator can't figure out or realize is happening. Anyway, so this plate is the aluminum plate, and that's connected one wire to the Avermenko plug, two 4148 diodes, one forward and back, and the load's all in series, and it just compels it to go like this, and meets the low potential here. So adjusting this, adjusting these, and adjusting that, even the ferrites and the capacitor were all pretty critical. Without the choke, I haven't actually tried it without the choke, but anything in a DC circuit can benefit from having some kind of choke that can store and return energy. And this is the waveform on the output, and you can read the same thing all throughout here. And that indicator LED is the one that kind of dims when these pick up and picks up when these go dim, indicating that there's some kind of added stress when it's out of tune. And earth ground, that was critical as well. The transistor is the MPSA06, and I think I've gone all the way around. Ends up being 1.6 megahertz, which is nice. It's just below the FM band, and the length of the inductor is 2.5 times the diameter. So that's I wasn't too concerned about turns. I was just looking at the geometry of the coil. So 22 turns secondary, 4 turns is what I had the tap on, and don't know how many turns, but it's 2.5 times the diameter, and then you just figure out whatever that ring's at and tune the rest to the resonator, which can also be manipulated with its capacitance up here. And like I showed before, too close is no good, too far is also no good, so that tells me that it's adjusting the capacitance. And that's about it. Talk to you guys later.